Manju. Prof. Manju, sorry, can you hear me?
मेरी आवाज क्यों नहीं आ रही? मेरा तो ये ऑन है, म्यूट भी नहीं कर रखा है। अब आ रही है? अभी मैं इससे लैपटॉप से कनेक्ट, हाँ तो शेयर करो स्क्रीन ना। हेलो, गुड मॉर्निंग एवरीवन, आई एम प्रोफेसर मंजू मांडोर from JRN Rajasthan Vidyapeeth deemed to be University, Udaipur, Rajasthan. I am very thankful to Honorable Vice Chancellor, NUST, Dr. Reynold Nam, and I am very thankful to Professor Dharam Singh Jijat and Professor Fangwei Shawa, Director of this ceremony, and all other dignitaries on the dais and all the participants. Today, I am going to present on this neurodegenerative disease using machine learning in the medical image processing. So nowadays there are some problems in neurodegenerative disease. So how we are using this machine learning in medical image processing. So first thing we should know about this, what is medical imaging and how we are using this medical imaging in neurodegenerative. So we can say this medical image processing is a computer advisable development in biological image to highlight some of its traits and improve the contrasts of this definition. The output can be actual the physical image and some individuality or some the parameters of that image. So how can we use this image for the description of the whole image in the computer vision or using this artificial intelligence technique? So this medical image processing, it's a technique and series of action uses this raise images in human body for the medical purpose and medical science also. So in the clinical context, medical imaging is generally associated to radiology or clinical imaging and the medical practitioner responsible for interpreting or acquiring the images for the radiologist. So medical imaging is very...
Prof. Mandor?
Yes, sir.
The presentation is not on slide mode. Can you move in presentation mode?
Screen is not sharing.
No, it's sharing, but can you move it in the presentation mode?
Your presentation is, I'm not audible.
Can you move your presentation in presentation mode?
Yeah, it's in presentation mode. Yeah, live.
It's not on the full screen.
Just a minute, just a minute. Some live, but no, it's not.
No, it's fine. You can continue.
Yeah. Just a minute. Now sharing.
Yes, Prof, you are sharing. We just wanted you to put it on full presentation mode.
It's sharing?
You can click by the icon close to the Zoom icon, just to put it on full screen.
So we can say, so how these imaging techniques are using on this human brain and how the human brain interprets these images. So, so we discussed how many types of devices and procedures to test the patient brain. So there are some many parallel to noise in natural sciences and few similarities in medical imaging in terms of grouping. So survey the medical imaging image processing methods and find out several knowledge of this defects and the need to develop the automatic representation of image analysis and the identification of the brain structure in the medical image that differentiate the healthy tissues from a pathology. So some artificial intelligence framework built as multi-stage hybrid organized information processing workflow, and we identified the benefits of applying these models for the medical diagnosis to create intelligent physician aids with the knowledge clarification. So especially knowledge embedding and increase the analytical precision. So we have used this computational model to apply to the clinicians with the assessment of the disease, and the taxonomy of the computational model has to be described. So use the different methods for diagnose the some images from the medical using some medical images. So we can say the medical modality imaging modalities. Some modalities we can say it's a method of diagnose and some type of equipments we are using functional images of the body. So how we are using for this? Using with the radiography, ultrasound, computed tomography, and magnetic resonance images (MRI). So some image modality is the method of some diagnosis procedures. So we can say, suppose we are diagnosing any images. So there are, we can say the images has some low resolution in the 3D dimensions, and there are some high level of noises there. Sometimes it is contrast, sometimes it is geometric dispersion, and the occupancy of imaging artifacts. So in the ultrasound image or image MRI images, there are some noisy images there. So how can we reduce their noise and improve their features to generate very good image of this any 3D model. So there are some methods for using this. So we can say the noise is there, some unwanted effects that is producing in the image. So noise is the random distinction of the image type. So there are impulse noise, additive noise, multiplicative noise, and different noises. They have their own. How can we differentiate from each other? So we have just described there are different types of noises. So we can say it's some spackle noise. So the the image is not clarified, and the radiologist and diagnostic, how can we just see the very good very good the resolution of the display. Some noises are there, and we are using very different types of filtering techniques to reduce this noises. So diagnostic tools use symptoms, measurements, and lab finding, and return the graded list of diagnostics, and we recommended some remedies also. So the techniques we are using for this, ultrasound and MRI, and these are provides a large amount of high resolution data. Sometimes we are using the CT scan to identify such brain tumors and brain injuries, and but the resolution is not so much perfect. So the scan contains lot of knowledge, and that is helpful in determining between the some of the disease. So they have many advanced imaging techniques that are necessary for the diagnosis of particular brain disorders, or particular imaging technique is the best for general diagnosis. So combining medical imaging methods, so we should generate some unique signature for each tissue of the brain, and using these signatures to categorize the tissue in the variety of subtypes and variety of types. So it takes a radiologist several hours to analyze various type of image collection, and isolate meaningful features, and integrate partial findings to formulate a diagnosis for a particular patient. This means the machine learning algorithms are only practical at pre-processing and decoding image changes to the access possible brain anomalies. So some noises in any images. So how can we denoise this image using some machine learning algorithms for this denoising, and we are using some algorithms for the diagnosis of some images and the diagnosis of some diseases using this medical images, because the medical image contains a lot of knowledge. So we are converting this 2D image or 3D image into mathematical model, and then apply the machine learning algorithm to identify the problems. So there are some methods for denoising algorithms, and some linear methods and the non-linear methods. So how these methods are applying for this in medical imaging. So we can say the machine learning algorithms are using for the pre-processing and the decoding the images changes and access the possible brain images also. So machine learning systems can allow the doctors to immediately understand the patient, and radiologists are trained to how to detect this normal, regular, and general deviation from the images. So recent analysis suggests that advanced machine learning algorithms, and these algorithms improving the physician ability to diagnose the images. So we can say there are different filtering methods to filter the noise and the image problems. So some of the filters are linear filter and some of the non-linear filters. So I have described some sober filter, salt and pepper, low pass filter, high pass filter, and some non-linear filters, mean filter, Lee filter, linear filter, and other filters. So using some of the filtering techniques to reduce the noise in the image. So the purpose of this speckle noise and other noise using in the image to reduce the means we can improve the quality of the image and the visualization of that particular image and the easily diagnose the problem. So some of the methods we have used in this, and now we come on the topic of this neurodegenerative. So my research scholar Kavita Mundra has done work on this neurodegenerative to diagnose the problem, and some Alzheimer disease and some Parkinson disease, and how can we diagnose the problems using some machine learning algorithm. So we'll discuss on that neurodegenerative disease. This is Alzheimer disease, Parkinson disease, and motor neuron disease, and how can we analyze using this medical images. The World Alzheimer reports this show in 2015, 46 million people worldwide with this Alzheimer disease, and in 2017, 50 million people, and in after 20 years, it will reach about 75 in 2013 and millions in 2015. It's very fastest growing in the China, South Asia, and the Western Pacific region for this disease. So the graph will show the ratio of the increasing the patient. This is the neuron structure and how we are diagnosing this medical images. These are the structure of this brain of this neuron structure, and it's biological terms we have used. After that, my colleague will describe this neuron structure of this body. First, I will show that Alzheimer disease, Parkinson disease, and all these disease using some machine learning algorithm to identify the problem of this diseases. So what steps we have used in this? So I'll show you on that. Some gray matter, white matter, and CFF used for this to diagnose this. So it's the we can say this Alzheimer disease is, we can say this brain disorder, and how they just lost their memory and their thinking skills and the ability to carry out some simple tasks. How this happening day by day and how these are increasing. So this is biomarkers for Alzheimer disease, and will show in the after some times using this how this Alzheimer disease is using for that. She has worked on some data, ICISET data taken from the internet, and she just find out what will happen in the mild stage, in the moderate stage, and the advanced stage, and how we can diagnose using this disease progression. And some image modalities we have already discussed, how we are using this image modality, how this will work on this different types of diseases, and what will happen after using this. So this is the diagram for MRI scanner, and after using this MRI, and the result shown on this patient report. So some challenges and issue are there, and the objective of this neurodegenerative disease detection machine learning to ensure the effective feature extraction techniques to discover the weakness in the existing system, and providing solution to the diagnosis of the problem through MRI and some other, and to compare the different techniques that is already implemented on the MRI data and providing the best solution for that. This is the flow chart of the MRI. This is the flow chart of the proposed methodology. What she has done on that, first they take the MRI image and the contrast image enhancement is there, and then convert that particular image into 256 into 256 pixel size, and how to extract the feature, because if we are working on the particular image, we are just extracting some feature of that image for the better diagnosis. So using GLCM also and using FCM to calculate and the CNN for classification, and then repeat this iteration process, and some apply some analytical parameters and classification also done. She has also done some classification on this feature extraction, and then uses different types of algorithm for the comparison. So what we have done on this, so first we have collect the data sets and then use some feature extraction techniques, and using some machine learning algorithms, and we have used some software tools for that, and we just develop a model for to analyze this degenerative disease detection, and using some machine learning, and after using that model, we have taken some parameters to resolve that problem. So data set, what we have taken, this OSIS data set we have taken for this, and we have also searched some other data set that Biomedical Informatics Research Centers network. This is the feature extraction method, how we are extracting some features. So we can say this texture. Texture means is the property of any area. We are using some pixels and we are calculating that area for the segmentation and the image classification. So the flowchart shows this texture feature extraction. There is some statistical methods are there, structure and some models, and some other methods also. So general statistical parameters we are using in some statisticals, and we have used this fractal features and random field feature analysis technique for that. So in texture method, statistical approach, first order, second order, third order, and the higher order techniques for this. The approaches of the each texture analysis is different. So the first order is shown that gray level using first order statistics from the image histogram. Then just calculating the distance between features and find out the images output. And this GLCM techniques, this is the matrix in the form how we are calculating direction of any offset. We consider this theta horizontal 0 degree and diagonal 45 degree, vertical 90 degree, and back diagonal 135 degree. This is the co-occurrence matrix of any image, because what we are doing, we are using the MATLAB, using any 3D image and convert 3D image into in the matrix form. This shown is 4 into 4 matrix. We have just calculated up to 256 into 256 matrix for any particular image. Then this is the matrix GLCM technique, and this is features on co-occurrence matrix. So this co-occurrence matrix capture properties of any texture. What we are doing in this original image we are taking, and then applied the co-occurrence matrix and second order statistics also, and calculating this and generating this F1, F2 features of different types of feature of any image. How we are using this feature on this co-occurrence matrix. We'll discuss in detail also. There are some different feature extraction techniques are using some, like we are generating histogram, calculating this variance, means, and auto calculation, and but we are focused on this clustering techniques. So we'll discuss on this, how we are using the clustering technique in the medical imaging. So this is feature extraction, and my colleague will tell you about this.
Yeah, good afternoon, everyone. So as per my guide already discussed you, I go further. First, we are taking the different MRI images and apply some statistical and the gray level co-occurrence matrix algorithms, which are inbuilt in MATLAB, and through which we can extract 14 different features. And according to my proposed model, these features are applied in fuzzy clustering, that is FCM, fuzzy clustering methods. And through clusters, we can diagnose or basically classify the MRI images. Is it the patient is neurodegenerative impacted, or the Alzheimer impacted or not? So there are three types of machine learning algorithms, like supervised learning, unsupervised learning, and reinforcement. Everybody know basically the supervised learning technique, where the input and input labeled are entered, and according to that labeled data we can diagnose the output. In unsupervised, the consist of input data without the labeled output. And in reinforcement learning methods, basically totally based on observation, that the intelligent agent can repeat the action, and the reward for the refrain from action that are punished for. Means on the basis of rewards and action, they can classify the image. So in my research work, I am applying some FCM algorithms, means the clustering algorithm, and the output of that clustering algorithms are work input in a CNN, and on the basis of CNN we can classify the image. The patient is normal or mild Alzheimer or the moderate. So this is just a overview how the fuzzy clustering works. Basically, there are two types of clusters. Fuzzy clustering is unsupervised technique, comes under unsupervised method. Clustering is basically hard cluster and the soft cluster. Hard cluster means generally the K-means algorithm works on hard cluster. Hard cluster where the data set is clearly differentiated between, for example, the two clusters. It is also called crisp cluster, but where the images are overlapped. Images are overlapped, the clusters are not make very clearly differentiated. At that moment, we are approaching the FCM clustering method, because FCM is, according to my thought, FCM work on overlapped data set very perfectly. See, in MRI images, I saw the fluids are mixed together like white matter, gray matter, and the cerebrospinal fluid. And in the case of Alzheimer's, lot of plugs and tangles are present in between these fluids. So the cluster techniques, if we apply the K-means, it is not very clearly picturized as compared to in a case of fuzzy. This is just the fuzzy clustering algorithm. The steps after fuzzy clustering. First, we select how many cluster we are taking, that is in C. And after that, we can calculate the fuzzy membership value, and then compute the fuzzy centers. These steps 2 and 3 can repeat until minimum J value is achieved. That is the maximum membership value. So those data points which achieve the maximum membership values, they present in that cluster. So according to that, we can make 3 different clusters. The first cluster shows the normal for normal patient, second cluster shows for mild, and the third one cluster shows for moderate. After that, we can apply for classification the image. We can use the convolutional neural network technique, on which we can apply some convolutional layer with some ReLU activation layer, then pooling layer, and then after flattening, we can classify the image. So these are just the steps of convolutional neural network techniques. These are my proposed algorithm on which we can take some MRI images, and after pre-processing, we can expect 14 different features, 14 different statistical and gray level coherence matrix features, and then apply to FCM using 3 clusters, means the value of C. We can cluster that image, and on the basis of the membership max.
Can you hear me? Sorry, you have 5 minutes remaining. Can you please start wrapping up your presentation?
Okay, we'll just continue on that because we have limited time. So we can't explain in the detail. Some methods are there, and we have this is the proposed model for our research work. What we have done using this input image, and after pre-processing and some feature, we extract some features, and we'll get the very fine image. The resolution of the image will you can show the resolution of this image using this different type of machine learning algorithms. This is the we have also compared some models, some standard model, SPM model, FCM model, and the FCCNA model. So with the comparison of this and the result shown, this FCNN produced a very good result for the Alzheimer disease detection, and this is the classification of that method. So we could say this neurodegenerative problems now going very huge in all over world. So how can we just reduce the problem using this different machine learning algorithm? So we try our best using some algorithms in medical imaging, and our research work has done of this. The accuracy is very the FCNN algorithm produce very good accuracy of the result. Sensitivity is also very good, and specificity is very good, and the signal noise, I have already told you about the how there are different types of noises, and how can we are reducing that noises using some machine learning algorithm, and the result of this FCNN, and this FCNN classification performs a very accurate result, and the lack of functionality degrades the overall performance of the classifier. So some future scope is also there. Application we have used it, and thank you so much for this topic. Thank you so much, sir, because the time is limited and the topic is very vast when we'll discuss. So do you have any query about this?
Thank you so much for your presentation titled Neurodegenerative Disease Detection Using Machine Learning in Medical Imaging. Is there perhaps 1 or 2 questions from the audience? Okay, I can't seem to find or see any hand here. So I would like us to give a round of applause to the presenters. All right, so next on the program is the presentations by the different presenters. So I'm going to hand over to Prof. Vivek because he is the chair for the session. Prof. Vivek, can you hear me?
Yes, I can hear you. Am I audible?
Morning, Prof, and welcome.
Thank you. Thanks for the invitation. Thanks a lot, Professor Singh, for inviting me as well. Okay. So the next talk is from, can I see the next talk details? Is it possible? I think the next talk is from Naomi Jerson and Fungai Bunasawa, designing a security model for e-health system in Namibia. Am I right? This is the next talk.
That's correct, Prof. Thank you.
Okay.
Good morning, everybody.
Good morning.
So, can you hear me?
Yes, yes, we can hear you. Then go ahead with the slides.
So, okay, good morning, everybody. So, my name is Naomi Helson. So, the paper is actually titled Designing a Security Model for e-health System in Namibia. So, this is just a presentation outline. We are going to look at the introduction and the prior work, problem statement, objectives, methodology, result and discussion, a security model for e-health system in Namibia, and then model evaluation, model demonstration, contribution and future work, conclusion, and then the references. So at the beginning, we need to look at the basic definition of an e-health system, which is just the way of delivering health services to the public with the information, with the use of information technology. So this is this is now a way of delivering service to the patient, not replacing the old system of actually of going to the hospital with the paperwork and all those stuff. So the e-health system is gonna it uses the internet, but then this comes with the advantage that the patient's history will be at the same, like at the central points. Even the doctor can access the history of the patient without actually just asking what's wrong. Every time you go to the hospital, you have to explain. But then with the e-health system, with the database of all the patients and their medical history at one central point, it's very easy for the doctor to follow up on their medical history, and also for the patients to access their medical information at any time, anywhere. So however, where there is advantage, there are also some disadvantages. So this information can actually be accessed by the people that are not supposed to be accessed this information. The cyber crime, the cyber that involves cyber crime, people that are actually just trying to hack the system and access this information. So information need to be secured during its inception, during transmission, and also during storage. So in Namibia, in 2011, Namibia also have implemented an e-health system, which is called Integrated Health Management System. And then according to one of the studies that was done by Bala and Ms. Fungai, the assessment of security requirement on the system implemented in Namibia Hospital, the outcome revealed that the e-health, most of the e-health security control measures were not in place. And also in 2020, the Global Security Index classified Namibia as a potential as a potential haven for online criminal. So which means our Namibia system can actually be hacked, and that include also online services like e-health system. And also Namibia was ranked 155 among 104 international telecommunication union. The members then regional ranking Namibia 32 among 43 African countries measured for their commitment to cybersecurity. So actually Namibia is ranked low when it comes to information security and cybersecurity. So regarding to this study, there are also some of the prior work, like the works that are already done by some of the researchers that already implemented some of the e-health security models, like the context awareness security model, the trusted visual domain, ciphertext policy, attribute-based encryption. So they have some weakness and also some strength, but then in all these models that are already existing or that were already developed, the researcher have found out that those models lacks mechanism to measure accountability as well as verification of users to be registered in the e-health system. So the proposed e-health system, e-health security model will cater for verification, authentication, and authorization as well as accountability. So that is what we have looked at. When we look at this e-health model that are already existing and we have studied them, so we basically identified that it lacks some of the security measures. And then the new e-health system that will be proposed, the model that is proposed, it actually caters for accountability, authentication, and verification. So the problem statement, so what actually drive for us to come up with the proposed model, it's actually through literature review and previous study on assessment of security requirement done on e-health system in Namibia hospital. The problem was identified as Namibia lacks security models to guide the Ministry of Health and Social Services on implementing e-health security requirements. Hence, the need to design a security model for e-health system in Namibia. And that is what the whole paper is all about, designing an e-health security model for Namibia, for e-health system in Namibia. The model objective is actually to offer security mechanism and ensure that the patient's electronic health records is protected during its inception, during transmission, and during storage. And also to ensure that the patient data confidentiality and data integrity is maintained. So every research that is done, it also does have a methodology on how you go about doing your research. So that includes the research design. The research design implemented for this paper was design science research approach, because we are actually basically trying to come up with an artifact. So when you are trying to come up with something, so the best approach, the best method that you can use is actually design science research approach. And that is what we have implemented. And the research philosophy, we have used pragmatism. See, this is because this study implement actually mixed method, which is both qualitative and quantitative. And also because we are actually implementing or employing design science research approach, pragmatism deemed to be the best suits for the research philosophy for this study. So the data collection used for this study was expert review, desktop review, experimentation, and online survey. The sampling for this study on how we select people that will be involved on the study, we actually wanted to get people that are expert on the area that we are trying to research. So we have used purposeful sampling methods, especially that we actually try to get the expert review. We have selected people that got the knowledge on information security, and also we also take people from the Ministry of Health that actually know in the environment of the e-health, or where we actually took the nurses, the doctors, those are the people that actually work with the patients mostly. So that's why I'm saying here, we have used purposeful sampling method. And the data analysis that we have used for analyzing our data, we have used statistical package for social science study, because this is the most common one that you usually use to analyze our data. So when you actually use the data, when you use the design research management, there are actually some steps that you need to follow for you to come up with an artifact. The stage 1, awareness of the problem. This one was done through literature review and previous study that was done on e-health system in Namibia. And also the stage 2 is suggestion. At this point, we're actually trying to get the composition of models. So what are the components that will be there for us to come up with the model itself? So with suggestion, we come up with the components. Those components need to be related together, and then the explanation and the guidance for implementing the model. That will now give you the model. Still on stage 2, you have to identify the components that needs to build up that model. So at this point, we actually look at the business model for information security. There is actually a well-detailed those elements, we integrated them in our study because we see them like they actually best fits what we are trying to come up with. There is organization, process, people, and technology. And then in relation to what we are trying to achieve or the model that we are coming up with, it have there must be an organization, which is now the medical institution, the process, which is the security policies and standards, the people, which is the medical personnel, the patients, and the IT personnel. And then the technology, which is now the e-health security mechanisms. So those are the components that we identified. And below here is just how they relate to each other. So the drawing below is just how those components relate to each other. And stage 3, that is now where we do the development of the e-health system that we come up with. So we actually come up with the e-health security model, just the drawing. And then the drawing later got transformed into an e-health web application, which actually used the platform called XAMPP, and also integrated with some access control mechanism and some encryption techniques. So the proposed e-health security model, this is now the first model that the researcher came up. That's the one that we came up, the overall flow of the proposed e-health security model before evaluation. So what we came up with, it was first the medical staff need to be verified. We suggested there should be a connection between the database of the Ministry of Health and also the database for the health professional, the authority. They also have the database. So before the medical staff is registered on the ministry's database, they need to verify that this person is actually authorized to offer medical services. So, and then this whole thing is just showing the flows, the patients. So if the medical staff is not existing on their database, then she will not be able to register. But if she's verified and the verification shows that this person is actually exists in their database of the Health Authority Council, then the medical staff will then be able to register on the system. This is done to avoid some dubious medical personnel that claim to be doctors and nurses, dentists, but they are actually not. They are not actually who they are. They are just trying to take advantage of the RAF system. So this is now the system that, I mean, this is now the initial model that was sent to the expert review and also to some of the IT technicians at the Ministry of Health to see if this is if it's this model does flow like the existing, like how the system's supposed to be. So this was just an initial model. And then the expert review actually then have to evaluate and then come up with their own idea and suggestion and comments on the improvement of the model. So we are still on the stages of the design science management, which is now the first stage. It's the model evaluation, where we were trying to get knowledge from the expert for us to improve the artifact security mechanisms. And also to the experimentation that was done at the Ministry of Health. It was also to measure the model's usability in the Namibian public health sector. So that is the stage for evaluation. That was done at the stage of evaluation. So so at this stage, it's just the suggestion and comments from the expert. Not all the experts have gave comments. Some they just answer questionnaires, and then there are those that actually gave comments. So if you look at here, there's comments, and then there's also the improvement that was done. After we get the comment from the expert, we try to implement what they suggested so that we can improve on the security in every flow of within the model. So all this, they are just expert comment and suggestion. Especially expert number 6 really gave a lot of suggestions. We say this expert really contributed to the final refined e-health security model that we are proposing. So all this, they are just expert recommendation and suggestion, and how we have tried to implement those suggestions. That now led us to the final refined e-health security model. And this is now how it actually looks. And this is the final refined e-health security model that we propose for the study. So after the model after the model was refined, that model was then developed into a web e-health system. This web e-health system was then demonstrated at the Ministry of Health, basically at the Windhoek Central Hospital. So the researcher presented the e-health web application to the IT team of Windhoek Central Hospital, as well as some of the medical team, by demonstrating how the application worked. So thereafter, the IT team and the medical team were asked to practice using the real life scenarios, whereby the IT personnel register the medical staff and patient in the system, assign them some roles, and gave them the login credentials. So the medical team were then asked to log on to the system and attend to the patients as per the normal practice, from the nurses to the doctor and then to the pharmacist. So the researcher shared with the participant the link to the proposed web application to experiment with the system and complete the evaluation form. So that was the demonstration done with the web application. We actually came up with the real life scenario, and then the medical team and the IT team actually they ran through just like the normal practice. So for them to be able to answer some of the usability question and security question that we were trying to get information from them. So if you look at this slide, it actually shows you that the e-health system was actually offering an option to register. And after you register, then you'll be able to log in. And then if you log in with the wrong credential, it actually gives a warning that's wrong credential, or sorry, provide with the wrong provide correct login credentials. So that shows that the system can actually interact with the user. The system does also integrate security, because only people that are registered in the system will be able to access the system. So also there is, well, we mentioned that this model will offer accountability. So there's also this audit trail that once you log in, it also capture who logged in, what time you log in, from which station, all those. So it really shows that there's actually security that's implemented in the system. Although maybe there's also some other column that need to be added on the audit trail. So this was just for demonstration. So to us, we feel that this model will actually contribute to, it will promote centralization, which means the information the patient's information will be at the central database, that once you go to any, whether you are at the north or you are in Windhoek or you are at the south, your information can actually be accessed without actually going to the hospital, give explanation of your medical history. But once the medical personnel log on to the system, they'll be able to try to access the patient's medical history, which will then will enable the medical personnel to prescribe the proper medication, because the person's medical history is already there. You just need to follow up without the patient explaining over and over and over. So it also eliminates dubious and unqualified medical personnel. So because before the person registered on the e-health system as a doctor, we need to verify that this person has actually registered on their Health Council database. The verification needs to be done before you practice within the public health sector. You must be already registered there. So there are cases, especially in Namibia, where people were already practicing. Some were already dentists, but it's actually just people trying to make money, but they are not really doctors. So if we have a system, an e-health system, that actually, before you practice, you register in the system, in the public e-health system, we are going to eliminate some of these dubious, unqualified medical personnel. So the system also gives an environmental friendly platform, because now we are going to replace the paper-based system. The paper-based system, actually, it can cause retailing and all that stuff, but where the information is captured on the e-health system, there are actually soft copies and all that stuff. So we are not going to have papers all around. So, and in the future, a similar study needs to be carried out in the country's private health sector. So with the idea that the private health sector and then the public health sector can actually be combined and have one e-health system, so that when you go to the private health sector, they can actually reach or access your information when we were at public health sector. Then they can just continue on your medical e-health, medical history. So in conclusion, this study focuses on designing a security model for e-health system in Namibia with the aid of design science research management. A secure model will benefit all patients whose medical records are captured, transmitted, and stored electronically in the public health institution system. Patients will be confident that their medical records are kept safe with minimum exposure, and will give Namibia's public health sector a good reputation. So these are just some of the references that were used in this paper. And if we maybe have any question, then can ask.
Your question?
Thank you.
Good morning, Naomi, and thank you for very interesting presentation. I have a question though, noting that the Ministry of Health has a system called eHealth, and it's in Central Hospital, Victoria Hospital, and Shakati Hospital. So it has been in place for some years. I'm wondering, your security framework, can it be integrated with the existing systems, and how?
Thank you for the question. So during the study, I've actually found out that this system it's non-existent anymore. The eHealth system at those hospitals that you mentioned, it's no longer there. Apparently the database crashed and they couldn't get the experts to work that out, but I understand they are actually working on something now, something new, but the one that you mentioned, it's no longer there for some years now.
Yeah, the question is meant to point out that if there is something in existence, can it be revived with the proposal that you are making now?
Yes, we can actually do we can maybe go through channels and see, and just to see if they can actually agree to integrate. At this point, I don't know how far they are. They were working on something with an international company. I don't think it's already implemented at this moment. But when I presented this one, they were actually happy with it. And that's just the system administrator and some of the doctors. But yeah, it's something that we can look at. We can maybe go through channels, the executive director, and then we'll see how far we can go with it.
Thank you. We have another question.
Thank you, Ms. Naomi, for the presentation. This is Cynthia Hotel. It's indeed a very interesting study that you are doing. I have two questions. You were saying, okay.
Excuse?
The first question is, you spoke about the eHealth system that you are introducing. And you said by registering, experts registering to the system will confirm their expertise for them to be the doctors or the dentists. I would like to find out, how will your system identify that this person who is registering, because you didn't talk about how the system will confirm that the registering person is indeed a true expert or health expert. The second one is, I wanted to find out on the experts that reviewed your research. Did you consider the Department of Health Information System that is existing within the ministry? Because I'm aware that there is an existing health information system, the district health information system in existence. And also adding to Dr. Swama's question, if the system that you are introducing can be, did you consider this system for you to integrate the two systems? Because some of the things that you are introducing in your systems are already in existence with that system. The last one is, okay, I think I'll stop there. Thank you.
All right, thank you. Your first question is how the system will actually find out that the person is registered in the health council system or not. What we are trying to propose is it's a way to for this database of the Health Council to be actually be accessed or to be queried before the medical personnel registered in the e-health, I mean the government e-health system. And then the last question, you are talking about duplicate roles that might be existing on what I'm proposing. What I'm proposing might already exist or available on the existing system. So once you once we came together with the Minister of Health, we can actually try to see which one is duplicate. Then we can get rid of what is duplicate. Then we can just concentrate on the new stuff. That's just what I'm thinking that should be done. What is duplicate, what is already existing there can actually just be there, and we add what is new that will actually work well with the e-health system.
Maybe just to add more clarity, when we started the research, we were using the system that was in existence. We verified the weaknesses of that system. However, the disintegration comes with the different systems that are being adopted by the Ministry of Health. They have donors that come and develop systems for them. Then they don't offer support beyond that. So there is no continuity. And based on what we found is existing needs and what was in the existing systems, we simulated or emulated that system with the guidance of the practitioners and the users of the system to come up with exactly what they would need. And the verification of the system comes through the linking to the different existing databases of professional bodies. So for all medical professionals, they're supposed to be registered with the health body for Namibia. As such, we can verify whether the doctor or nurse or pharmacist is part of that database. And if they don't qualify when they're doing self-registration, then they are not authenticated. And it also takes into consideration the biometrics. So we can physically identify the person through their biometric markers, as well as the information that is existing in the database to ensure that there is no fraudulent activity. Integration is a key aspect, but as we were designing the solution, the security aspect of the health systems, we could not look at the integration of existing systems since they've disintegrated systems and they've not defined or identified which one they'll go with. So we are still going to continue with this work, and as they come to terms with what they need, we will adapt our system to facilitate the integration of the other data that I have with the systems that they need to be integrated in the system.
Thank you, Prof. One more question. Okay, I've been trying to follow what you are presenting. Security for country. One of the aspects I want you to clarify is that you are most people are talking about the human resource, doctors, nurses, and so on. But you're not talking about, okay, I'm from Uganda. We have a national drug authority. We also have a standards. These look at drugs, monitor, they give them ISO numbers and certifications. I don't know whether your system is going to address aspects of fake drugs, how they will be used, so that to have a secure health system, you must address the drugs, the medicines. How is your system going to address?
I didn't hear the question well. The sound quality is really not.
I'm addressing the drugs. Are you getting me? Can you hear me? Hello?
Yes.
Yes, I'm addressing the drugs. In order to secure a very good, secure model system in a health system, you must have proper and not fake drugs. And in some countries, we have national drug authorities We also have a body that looks at certified or original or proper used drugs. So I'm not sure whether your system is gaps so that you can secure a very good secure model for the drugs.
Can you maybe put that question in the chat?
Okay, I'll answer the question. The drug security is outside the scope of the research. We're looking at the integration of the information systems, not necessarily verification of drug authenticity that we believe is a pharmaceutical process, and we are not dealing with that in this research. Thank you.
Okay, thank you so much. Back to you.
Thank you very much, Ms. Naomi, for your presentation. So next on the program is a presentation by we have a presentation by Vaishali Kalpana Kadale Namrata Maheda. Are you online? Can you hear us? All right, I don't seem to see any of the authors online. Do we have Suvanama Paga and Ranadip?
Yes, ma'am.
All right.
Are you able to listen me?
Yes, we can hear you.
Hello.
Okay, ma'am.
Hello. Dr. Anthony Anya on the line.
Okay, ma'am.
I was supposed to present yesterday at the 5 section, but while I was presenting and my battery went off, there was no other way I can get another source. So I tried all means. So I had to send a message that I want to present this morning.
Hello. Hello.
Hello, ma. Dr. Anthony Anya from FUT Mina, Niger State, Nigeria.
Sir, actually, just a minute, sir. I am presenter. So
Okay.
you need to request to conference coordinator. I am just presenting. Now they announced my name. That's why I need to present my PPT. So so you need to contact with coordinator. I am presenter in this conference.
Presenting already.
Yeah, but I can't hear. Ms. Banga, can you go ahead? Can you hear me? Where is she here? Don't even see her. I want to check who is there because we can't see. She maybe can't hear us.
Hello, ma'am. Are you able to listen me? Myself, Suvarnamala Bangar. Hello. Hello.
No.
Should I start my presentation? Yes. Should I start my presentation?
Yes, please, you can start. Thank you.
Okay. Thank you, ma'am. Good afternoon, all. Myself, Suvarnamala Bangar, pursuing a PhD under the guidance of Dr. Ratnadeep Deshmukh, sir, Professor in Computer Science and Engineering Department. And I'm presenting my research paper on remote sensing and machine learning technique for development of e-governance system and smart city. And it's a review paper. And I'm presenting this paper in International Conference on Data Science, Machine Learning and Artificial Intelligence. The contents of my presentations are introduction, the work related to this particular topic, then what methodologies are used earlier in the, to develop this topic, then the remote sensing and GIS for smart city and e-governance.
Hello.
Hello. Huh? Yes, ma'am.
Presentation mode.
Okay, wait a minute. Just a minute, ma'am. Thank you, ma'am. So these are the different contents of my presentation: introduction, related work, methodologies, remote sensing and GIS for smart city and e-governance system, then machine learning for smart city development, and then conclusion and references. So almost in every country in the world is working on designing and developing a smart cities. And the goal of planning and developing a smart city is to increase the people's quality of life while also saving the time and efforts. So Amsterdam is known as the world's first smart city, and China set a goal of designing a 300 smart cities. And likewise, India set a 100 smart cities goal of 100 smart cities for development of with the better quality. And they allotted a 720,000 crore budget for the development of smart cities in India. The smart city mission of the Indian government goal is to spur the economic growth and improve the people's quality of life by facilitating the local area development and utilizing technologies, particularly the technology that leads to a smart results. So government agencies, then education institute, and businesses are all the part of this planning and development of smart cities. Every country want to develop the smart city because they do this thing by having 4 different factors, like they need to concentrate on transportation, then healthcare sectors, then standards of people living, then smart services in every sector. By considering all these factors, depends on being economically strong, the countries can be the stronger, and recognizing their country internationally all over the world. Building the smart cities are required the technology for various purposes, and the fundamental technologies are huge network connectivity, which we required whenever we are going for development of smart city. Then cloud storage, data mining, and analytics. Then IoT things are also needed, are there. Then machine learning and artificial intelligence, remote sensing, and GIS things are needed for the development of smart city. The primary goal of e-governance is to provide a citizen-centric service facilitated by the information and communication technology ICT. Regardless of the level of smartness pursued by a city, the e-governance deliverable are seen as a critical for a nation. So to build these smart cities, we need all these things like network connectivity and cloud storage and the Internet of Things. And today's e-governance activity are focuses on collaboration across the groups such as the businesses, civil societies, governments, and people.
Sandra, can you hear me? Hello? the next presenter. We have Mohammed Hassan. Mohammed, can you hear us? Or Ramesh Sama, any of the authors? All right, Anthony, can you hear us? Anthony, can you hear us?
Hello.
Yes.
Yeah, my name is Blessing Gwembe. Can I share my?
Like to proceed?
Yeah, can I share my screen?
Yes, you can share your screen.
All right, awesome. Thank you. Can you see my screen?
Yes, we can see your screen. Just please put it on full presentation mode.
Sure, I'll do that. I'll do that. All right. Good morning, everyone. I hope you can hear me, right?
Yes, we can hear you. Please proceed.
All right, my name is Blessing Gwembe. I'll be presenting a machine learning technique for automatic long test examination in open distance learning. So these are my presentation outline. I'll go through the introduction, the problem of the study, aim and objectives, the mapped out methodology, then the proposed framework. Then we are going to take a look at the data description as well as the experimental results, and then the conclusion. As a matter of introduction, educational technology or open distance learning is basically a type of education that uses technology to connect learners, teachers, and educational materials from different locations. And the major objective of educational technology, or say ODA providers, is to develop an educational experience that encourages learners. Due to the increasing awareness of educational technology and ODA system for expanding access to education, it has become pertinent to develop and maintain quality processes such as assessments and examinations if ODL is to be adopted or is to complement traditional educational institutions. Examinations are essential activity for assessing the abilities, knowledge, and level of understanding of open distance learning students. Hence, it is essential to implement quality examination or assessment infrastructure for open distance learning platform, which will enable open distance learning institution evaluate the learner's level of understanding as well as performance. Though there are existing electronic assessment and examination system, for example, we have mock platforms like Moodle, Udacity, and so on and so forth. But this platform carry out assessment based on, let's say, multiple question type, a single type questions like SCQs, as well as sub-objectives and short test questions. A problem of this statement, like I said before, there are many existing automatic assessment tools in ODL platforms like Moodle. However, these tools are limited to subjective, multiple choice questions, true or false, and single choice questions. In existing platforms like D2Learn, Moodle, Blackboard, eRater, and so on and so forth, they have like some sort of short test similarity matching tags. However, this platform cannot really grade long test questions. For example, let's say 1,000 to 100 or 500 like sentences and so on and so forth. Most existing system also supports automatic short test similarity grading tags. Like I said before, it's very limited to 17 to 20 word count and so on and so forth. Given these challenges, there is need for a better approach that addresses this limitation and provide a feedback and high level of performance accuracy in grading long test examination, or let's say similarity matching attacks. So let's take a look at the aim and objective of the study. The aim of the study is to develop an automatic long test grading model for open distance learning courses using machine learning approaches. The objective of this study include one, to design an automatic long test grading framework for open distance learning systems. Two, to implement a proof of concept based on the design framework. And finally, to evaluate the proof of concept with standard machine learning evaluation techniques such as accuracy, precision, recall, and F1 score. So I'm going to take you through the MapBack methodology. In order to achieve objective one, we utilize the concept, or let's say we evolved a two-top monolingual aligners for paraphrase detection and long-term similarity matching tags. We also introduced the concept of cosine similarity matching techniques for similarity matching tags, as well as matching sentences and so on and so forth. So we also, in order to achieve objective two, we utilize Python programming language. We also utilize several machine learning techniques such as support vector machine and so on and so forth. And we utilize, like I said before, cosine similarity matching tags and the modified Hewlett Foundation automated assessment price data set, which is basically a short test and long test similarity matching data set. Then to evaluate the model, which is objective three, we utilize standard machine learning evaluation techniques. We also evaluate the implemented model with a group of students at Covenant University, Nigeria. So this is the proposed framework. And the proposed framework, you can see that we have the examiner's question. We also have the student answer. The examiner is responsible for setting up the examination questions as well as grading the students. So what we do over here, let's say we have the input set. The input set, we have the examiner, let's say, marking scheme, then we have the student answer. So we carry out the whole pre-processing thing, then as well as training our model with our machine learning techniques. Then we integrated our two top monolingual aligners as well as our similarity matching schemes such as cosine similarity matching. The objective is to take a look at the accuracy of matching the examiner's marking scheme as well as the student answer, then generate the result based on certain level of accuracy while executing similarity matching tags using and paraphrase detection using two top monolingual detection as well as cosine similarity matching attacks. So I'm going to take you through the concept of semantic similarity matching. The semantic similarity matching is simply a technique that defines a set of terms or, let's say, test document. This method basically execute the similarity between, let's say, tests by computing the cosine. This test can be either 2 sentences or 3 sentences, as the case may be. So cosine similarity matching is actually a mathematical technique that is used to derive semantic similarity matching based on analysis of, let's say, word-to-word co-occurrence in a collection of sentences. So we are basically introducing this mathematical concept into automatic grading tags, where we basically want to match the similarity between sentences. So let's take a look at the function of the cosine similarity matching tag. So the cosine similarity matching tags basically makes it possible to compute similarity measures for adverbs as well as adjectives, not limited to verbs and nouns. The cosine similarity between two vectors, or let's say two test documents on the vector space, is a measure that evaluates the cosines of the angle between them. And it basically generates a metric that says how identical two tests or documents are measured, or the orientation of, let's say, two tests and so on and so forth, as well as their magnitude as shown in equation 1.1, 1.2, 1.3. So if you take a look at the next slide, you see the formula or the expression of the cosine similarity matching we are basically adopting for similarity matching as well as similarity ranking. So for example, let's say we have two sentences. Let's say we have the sentence one as the examiner's marking scheme, then we have sentence two as the student answer. So imputing this into the cosine similarity, we can say that, oh, sentence one, Blessing eats more food than Emmanuel does. Then we have sentence two, Emmanuel eats less food than Blessing. So if you take a look at it, you see some sort of similarities. But if we want to if we don't consider concept like, let's say, paraphrase detection, then we are going to get a very low accuracy, because we can basically use any names to answer this particular question, right? So in this case, the student is using Emmanuel. So if you take a look at it, we can say that, oh, the similarity matching is 1-1. That means it's 100% for Blessing and Emmanuel. Each can give us 100%. But if you take a look at more or less, though we have the same meaning too for the both sentences, right? But it can give us a very, it can create some sort of misclassification rate. We are going to look at that when placing these whole sentences into the cosine similarity matching formula. So if you take a look at it, we have sentence one and sentence two. So sentence one, we have Blessing Emmanuel. So the score gives us what? 100%, 1-1. Then we have it, which is 1-1. Then we have more or less 1-0. So putting this whole thing into the cosine similarity expression, we are getting a prediction accuracy of 0.76. Which is for the cosine similarity matching task. Then we are going to see how we can apply machine learning into this concept. So these are basically the block diagram of the cosine similarity matching task, where we have the examiner reference answer, which is basically the marking scheme, as well as the student answer. So here we have a collection of terms and, let's say, check of elements in a distinct form. Let's say we have a student answer that is quite different, but with the same meaning to the examiner's marking scheme. So we want to carry out some, distinct function, or let's say aligners or paraphrase detection, to ensure that, we are actually grading the students the right way, and so on and so forth. So over here, we are creating a vector space using term frequency. Then we evaluate and compute the similarity matching using cosine similarity matching. Then finally, the system model automatically generates the result, and so on and so forth. So we are going to take a look at the design of the paraphrase detection. The objective of the paraphrase detection is to determine if two sentences have identical meanings. Here, the two top monolingual aligners for a paraphrase detection task and aligners for sentence and word aligner were employed and designed respectively. The aligners operationalize the, let's say, simple hypothesis that related words in two sentences or snippets can be identified using some sort of similarities in their own meaning and context. So I'm going to demonstrate a few concepts, or let's say examples. So for example, if you take a look at this paraphrase detection, you can see that we have some sort of rows and columns. So if you take a look at the first row, you can see that we have one as Holland and we have another one as Netherlands. So if you take a look at it based on paraphrase detection, it will definitely tell us that, oh, there is a pair of tokens that is basically related based on meaning. So if you take a look at it based on similarity, as in terms of matching these words, it's going to give us 0%, right? But if we want to add paraphrasing into this concept and we want to add some sort of meaning into this, then we can say that Holland and Netherlands basically the same country, right? Or the same terms, or they are basically giving us the same meaning. Then we also have troop and army. We know that troop and army, they are the same thing, but if we want to look at, similarity based on similarity matching, it's going to give us the wrong answer. It's going to give us 0. But in this case, we are adding paraphrase detection into consideration. Over here, we have 4. We have storm and crash. We have jail and prison, and so on and so forth. So this is basically the implementation concept of the two-top monolingual aligners. So data set description, like I said before, the automated assessment price data set from the Hewlett Foundation was used in this study. The data set was partitioned into 8 sets, each with its domain, and this allows for domain diversity in the data set. So each data set basically contains staff questions, answers, as well as grade for the training and testing set. You can see that we have set 1, set 3, set 4, and sets. See, they are basically divided into the training as well as the testing set, which is 70 to 30%, and these are average word count. So in this case, for test set 2, we are taking a look at 500 word counts. For set 3, we are taking a look at 350 word count. For set 4, we are looking at 400 word count, and for set 5, we are also looking at 500 word count. So after implementing the cosine similarity matching, we benchmark with existing similarity matching test technique. Then we can see that the cosine similarity matching technique outperform other existing techniques in literature. We also utilize other machine learning techniques such as k-nearest neighbor, random forest support vector machine, logistic regression, naive Bayes decision tree, as well as artificial neural network. We can see that support vector machine outperform existing machine learning techniques in terms of similarity matching and in terms of predicting, let's say, student answers and examiners marking scheme. Hence, we decided to use as a support vector machine for this particular task. So combining support vector machine and cosine similarity machine, we achieve a very high accuracy, which outperform existing study in literature. Conclusion: this study implemented an automatic long-term examination system for open distance learning courses using support vector machine and cosine similarity machine tasks, as well as two-top monolingual aligners. The accuracy was measured, and the results showed that the accuracy of the implemented system is 80%, which is very good performance accuracy, but still needs improvement. This means that the proposed model will return a very good result by saving effort and time in terms of grading long-term similarity tasks in open distance learning platform. Thank you. Any question? Hello.
Thank you very much, Blessing, for your presentation titled Machine Learning Techniques for Automatic Long Text Examination in Open and Distance Learning. Do we have any questions from the audience? Okay, we do have a question. Just hold on, Blessing.
Is that?
Just hold on, there's a question for you.
Thank you.
I can see. All right.
Thank you, Blessing, for a very interesting.
You're welcome.
Thank you, Blessing, for a very interesting research.
You're welcome. Thank you. Thank you. I appreciate it.
Okay, so my question is, okay, on your results, the evaluation metrics you used, obviously they reflect some good performance, but I'm just curious whether there is, you are able to find a parallel type of evaluation by using a human, like human evaluation.
Yes. Yes.
Of your model by using a human result. Let's say I'm a lecturer, I would like to assess your model and see if whatever your model achieved is relevant, is similar to what I would have awarded for a certain assessment. Yeah, that's the question.
I didn't really get what you're saying. If I understand, okay, you're trying to ask if we actually evaluate with human graded questions, right?
Yes, because okay, it's to say yes, we can trust computers, we can trust a deep learning or machine learning model, but who knows? it might have some biases. So if I'm a human being evaluating the same way.
Oh, awesome. I understand your question, right? So one of the objectives of this research is to, test run this model in, like I said before, in Covenant University. We basically use some set of students. We use about 200 students to evaluate this particular model, because the model was actually deployed on a real life system. We basically deployed the model weight on a web solution where we built, let's say, a long test platform or examination platform where a student can basically take exams and all of that. So we captured the model, the result generated from the model, as well as the human graded tasks. You get? So at the end of the day, we decided to carry out evaluation to obtain the average result of the 200 students. And the result shows that we achieved 80%, which is the same as that of the what? Of the machine learning model we actually implemented. So we did all the testing and all of that. I think it's on the main paper. So though I didn't extract that into the PowerPoint presentation, it's also there. But if you take a look at the objective 3, you will see that we actually test run the implemented system using a set of group of students in Covenant University, Nigeria. Have I answered your question? Have I answered your question?
Yes, please tell him yes. Says that yes, you have answered his question. We have one more question.
All right.
All right, no more questions. Thank you very much again, Blessing, for your interest in presentation.
Thank
you can stop sharing the screen. Thank you. Anthony, can you hear us?
Good morning. My name is Dr. Anthony Ania from Federal Institute of Technology, Mina, Niger State, Nigeria. The title of my conference paper is Educational Technology for Sustainable Development in the Era of COVID-19 Pandemic in Nigeria, Problems and Prospects.
That's what I did.
You are hearing me, isn't it? Am I audible?
Yes.
All right. Let me go to my slides. All right. The abstract here states that the paper discusses educational technology for sustainable development in the era of COVID-19 pandemic in Nigeria, problems and prospects. Yes, Mr. Anthony.
Yeah, can you please share your slides with us?
Okay, I'll be fast. Okay. Literature review was used.
Can you see it now?
I can see it. Can you see this? The slide now? Can you see the writings?
Not yet.
I'm coming. Share screen. Okay. Okay. All right. Are you seeing it now? Is it? Are you seeing the?
Is it loading?
Is it okay?
Still busy loading. Yes, we can see it now. Thank you.
All right, well, thank you very much. The abstract says the paper discussed educational technology for sustainable development in the era of COVID-19 pandemic in Nigeria, problems and prospects. Literature review was used as a method of gathering information in line with the title of the paper. Also, the objective of the study was to determine the role of educational technology towards sustainable development during the pandemic and its disruption in the education sector. The paper concluded that educational introduction, okay. And the introduction here also shows, you can see by the right, we have the coronavirus, showing that this is the main part of what we are trying to study, its effect during this very, in Nigeria. So its origin is from Wuhan in China and became a major problem to nearly all the countries. Nigeria is not an exception. Adelakun, 2020, noted that the pandemic led to breakdown of most human activities that could have been responsible for human development and sustainability, such as education, fall of economic activities, sharp rise in underemployment and underdevelopment and underemployment. The pandemic led to lockdown of schools and its funding. Technical vocational education, TVET, programs particularly have been hard hit, given its unique focus on work-based learning and acquisition of practical skills, which is closely related to educational technology practical-oriented course in education. Looking at, by the right now, ICT has become the major way of transforming a society, development. So we link it with education and technology, which are they are important tools responsible for growth, development, and well-being and sustainability of any society on the globe. This can only be achieved through integration of innovative technology, which is the ICT, which are considered critical to attainment of classroom set of learning objectives and even to society at large. Education. By looking at the diagram, you know that education is a main focus here also in line with COVID-19, trying to look at the effect of education and COVID-19. So education is a strong factor that can determine the sources of sustainable development or driven development. UNESCO 2000 stated that education is an organized body of knowledge designed to communicate combination of skills, understanding, and values for activities of life. It is also used to solve human problems, improve life and make it more comfortable, and also bring about all-round development. That is quite true. Then, we are now in the internet world. Look at, by explaining, even at this time of COVID-19, conferences, just like the one we are holding now, you can be at the comfort of your home and then continue to present papers. Even conferences that have to do with health to improve society. So you can see that the role of educational technology play in the advancement of society cannot be overemphasized. It is a veritable tool for fostering development, acquisition of entrepreneurial skills for economic growth and sustainable development of any nation. Its advent has profound solution to most educational challenges faced by Nigeria, e.g. the use of internet, which we are seeing here, educational platforms such as Edmodo, Module, and among others. Sustainable development. This is one of the heart of this. Look at the diagram. Sustainable development in the center. This just like ecosystem. Without one of these, things will not be complete. The planet is where people live. Look at people there. And then we have to partner, they have to partner with themselves. And also there should be peace. In an environment that wants to have a sustainable development, there must be peace. And then that will lead to prosperity. Problems of educational technology. From these pictures that you see here, or diagram, from the down part, you see that the people are together. The next line, they are together. But getting up there, the man in the red center is dividing the system, those groups. So when you look at it, the first one said lack of leadership. Leadership leads without vision by stakeholders. Stakeholders find it to lead because of difficulty. They are now breaking away, making it difficult for people to come together to discuss how to sustain economic and bring about development. Then lack of training. Even in this present world of ICT dispensation, there is no how. If there is no training, there is no manipulation. Nobody can work, or people need training and retraining to be able to go ahead with this present dispensation, which is ICT, the digital aid. Then lack of proper mindset on the part of students. There are some students might be reluctant to learn this very new device, but it might also be that because to acquire the laptop or the computer itself is a problem. And then these are the things bothering the student. Some of them may be reluctant to learn, and some of them might think of how can I buy this thing? And when we say the internet, how can they even buy the credit that they can use to go ahead? Then the last one is ICT, lack of ICT enlightenment program on the society. It leads to some misconception, e.g. in the advent of, its advent was perceived by workers as an attempt to lay off workers instead of ease productivity, save time, thereby increase growth and sustainability. ICT initially is introduction in Nigeria here. People thought that the government wanted to send people out of their work, not forgetting the important or the good effect of it, which is to increase production, ease production, save time, and thereby increase growth and productivity. Prospect of educational technology. No doubt, educational technology, look at all these diagrams, and it's about educational technology in alliance with, so educational technology has made it possible to study from any location in the era of COVID-19 through online or virtual. It is a laudable achievement. For instance, World Health Conferences, online journal paper presentation were visible just as we are doing right now. Computer skills acquisition among students through educational technology-based ICT improve the quality of learning output. So we can see it gives skills to students so that they cannot rely on white-collar job or government. At the same time, it also helps in the classroom instruction. Conclusion. The paper established that the integration of new technology devices using educational technology-based tools has greatly helped in addressing challenges experienced by Nigerians as a result of outbreak of COVID-19. It has also advanced measures to absorb future incidents by developing educational blueprints to address prolonged school closure, reduce unemployment, hunger, and provide a good health program for the nation. Suggestions. Look at the pathway. This, what we are seeing, is a pathway to greatness, to success. But these are suggestions. If the government will take them, it will be good. If they don't take them, then but the right thing to do is to show that suggestion can make something better. Government should invest in development of adequate crisis response plan for education from national to down at a level like this COVID-19, so that something like that, there won't be problem. Provide improved internet productivity. If there is no internet productivity, then the communication will be hard, and they need it for us to move ahead. Develop and maintain easy access to distance learning platform. Collaborate with private educational technology sector and national level. Provide relevant training skills for youth and adults to meet current and future needs for sustainable development. Just as we have said that there is need for skill acquisition so that people can live, people can manage, even at the time that times are hard. And then this internet also could help in education. It could help also to keep the society going, communicate both outside and inside from wherever you are. References. Thank you for listening. Any question?
Yes, thank you very much, Dr. Anthony. Do we have any questions from the audience?
All right. Any question?
All right, there seem to be no questions from the audience in the room.
Right.
Blessing, is that a new hand? Blessing, do you have a question?
Yes, I have a question.
All right.
All right.
So I just want to know if this is a systematic review or a survey paper.
Again?
I said, I just want to know if this is a systematic literature review or a survey.
No, it's just a systematic literature review. Just review the paper. Like this is opinion paper, and you want to review. Yes.
Okay, if it is actually a systematic review, then what are your extraction and inclusion criteria? I can't actually see them on your paper, and I can actually see the sources you retrieve your literatures from, and as well as the keywords you actually utilize to retrieve those articles, because those are the basic component of a systematic review paper, or let's say opinion paper. So I think you should take a look at that. Thank you.
All right. But from the introduction of the abstract, just immediately after the abstract, you saw those keywords. There are those areas that I focused on. And when you come down, because I said, like the paper, why the educational technology, to find out at this period of coronavirus, what this education can do so that it can reduce these senses and problem relating to education and unemployment, because we are saying that people suffered seriously. People were indoor, people were not going out. There were sicknesses all over the place. So people suffer, even hunger. So if you look at those keywords, you see there were linkages from one segment to another. I try to link them so that I take from one, this thing, from one another, from one, this thing like the concept of education, educational technology, so one onto one until I got to the end. So that is just, by that systematic, I make it from one to another, linking them to another, that this is the way they should look. And I think from this review, it cannot be total, I know. So normally in any review, there must be corrections. But
what I'm trying to say is that,
yes,
right, before you carry out a search or extract documents from scientific database, right, you have to be like, you have to build some sort of keywords to execute your search criteria. So building keywords for search criteria is quite different from the author's keywords generated from the article, or the author's keyword utilized to execute some sort of, let's say, search engine search, which is basically different from that of, like, for example, you are executing a search query on Scopus or IEEE, you get. So
thank you.
You're welcome.
Thank you very much. You can take corrections, and you know that researches differ from one region to another to some extent. So that's what I want you to understand.
Thank you.
Thank you very much.
Right. Thank you very much.
I'm delighted for allowing me to present, ma'am. Thank you very much, ma'am. I'm grateful.
All right.
Yes.
Ms. Banga, are you online? Can you hear?
Hello, am I audible? Hello.
Yes, you are audible, ma'am.
Okay, ma'am. Thanks.
All right. We had lost you on the set, right? So perhaps you can continue from there.
Okay, ma'am. No problem. Okay, so quickly we will see what is the introduction for my paper. That is almost in every country in the world is working on designing and developing a smart city, and the goal of planning and developing a smart city is to increase the people's quality of life while also saving the time and effort. So Amsterdam is known as the world's first smart city. China set a goal for designing and developing a 300 smart cities, and India set a goal for 100 smart cities. And also India allotted a 720,000 crore budget for the development of smart cities in India. The smart city mission of the Indian government goal is to fuel the economic growth and improve the people's quality of life by facilitating the local area development and utilizing technologies, particularly the technology that leads to a smart results. Okay, so government agencies, educational institutions, and businesses are all actively involved in this planning and development of smart cities. So these are the four important factors which you need to consider when you want to develop a smart city. So the four factors are transportation, healthcare sector, standard of people's living, and the smart service in every sector. So building a smart city are required technologies for various purposes. The fundamental technology are huge network connectivity, cloud storage, data mining, and analytics. Then Internet of Things, machine learning, artificial intelligence, remote sensing, and GIS. Such are the different technologies which you need to use whenever you are going for the development of smart city. The primary goal of e-governance is to provide the citizen-centric service facilitated by the information and communication technology, that is the ICT. And regardless of the level of smartness pursued by the cities, the e-governance deliverables are seen as a critical for the nations. So building a smart city are required the cloud storage, then remote sensing and GIS, such type of technologies, and for classification, the machine learning algorithms, and somehow the artificial intelligence also. So today, e-governance activities are focused on collaboration across the groups such as the businesses, civil society, then government, and the people. So the work which is related to this particular topic and the paper are presented. Some of the paper are here, like GIS application for the road network of the Philippines, a new technology in the road management. The object of this paper is highway network management, road network management, and the methodology they use is GPS and GIS and traditional database application. Okay, the second paper we can consider here the e-governance for the Ludhiana Municipal Corporation. And the objective of this paper is collection of property taxes through the municipal corporation. And they use the satellite world view too, and the remote sensing, GIS, GPS, and ICT technologies. Then Surat Municipal Corporation also is developed by using this paper, that is web-based GIS application at Surat Municipal Corporation. And the objective of this paper is providing a web application, GIS-based application for the citizen of Surat Municipal Corporation department and employees also. And they use the methodology high resolution satellite images and RSGIS technology and GPS also. So remote sensing approaches to smart city development in India, and the case is Bhopal city, Madhya Pradesh. So this is another paper we can consider, which the objective of this paper is develop a rooftop solar photovoltaic system and the household level drain water harvesting. So the methodology they use is a remote sensing, GIS, GPS, and they also use the high resolution satellite images. So the work related, according to the literature survey, the remote sensing, GIS, machine learning, ICT techniques plays an important role for development of smart cities. And again, the following things are also important, like remote sensing and Internet of Things, information and communication technology, GPS and GIS also. So the common methodology which is used whenever we are going for developing any application for the smart city. So the remote sensing and GIS technology plays important role, and the development of smart city and e-governance system through it, we can do the urban vegetation analysis, then thermal condition forecasting in the urban area, then hydrographic geospatial analysis for flooding, hazard detection in urban area by using the multispectrum, infrared, and hydrological data. So developing a e-governance system is a part of smart city development. And for this, according to the objective of the project, various methodology and the planning we require. Okay, so here are the some steps which we need to follow. High resolution satellite image. First, you need to take an input as a satellite image, which should be a high resolution. Then next is pre-processing technique, which in this technique, what you have to do is you have to apply the techniques on this inputted image, and after having a image, you need to use the machine learning and deep learning algorithm for having the classification, and you will have the desired output. So remote sensing and GIS is the study of getting the physical properties of an area without actually visiting it. So we may categorize the images into land cover and other sort of analysis by gathering them. High resolution satellite images helps to recognize any object on the earth. The study shows that the remote sensing and GIS plays an important role in the development of an e-governance system and helps to become a part of the smart city. So high resolution satellite images helps to recognize the object on earth. This is the table which indicates the some list of some satellite satellite names with the resolution. So worldview is the satellite which provides a 0.5 resolution in meters, and the application which you can develop using these images are agriculture, mining, smart city planning, and so on. Then second, another satellite is GeoEye-1, which provides you 0.5, and the application which you can develop is engineering and constructions, defense and security, and environment management. Then ICONOS provides you 1 meter resolution, and cartographic, geometric, and various remote sensing application you can develop by using its images. Then QuickBird provides you 1.6 resolution in meters, and you can use these images for analysis of change in the land use, then change in the architecture, then if there is any change in the forest climate, then you can use the QuickBird's images. And then Cartosat is another satellite which provides you 2.5 minimum resolution, and you can use the cartography, then weather mapping, forest survey, urban planning, coastal study, mineral perspective, and other courses also, military purpose also. Such type of application you can develop by using these images. Then next we can consider here the GIS, which is also important part of development. So it is a computer system that capture, store, verify, display the data about the location on the Earth's surface, and GIS can display the wide range of data on a single map, including the streets, buildings, plants. So GIS is used by hundreds and thousands of companies worldwide to create the map that communicate, do analysis, and exchange the information, solve complicated issues. So GIS technology used for creating a geo-reference maps and digitize them through the collected ground control points and high resolution satellite images and in the image processing. So GIS system can manage the various tasks in a municipal corporation. Like you can develop a property task application, or birth and death registration application, then property valuation, searching a property if you want to develop, then application like building a permission, town planning, water supply planning, bridge development planning. Such type of application you can develop by using a GIS technology. Here are some software names which you can use during the development. So if you want to develop the 2D, 3D, and 4D data analytics, you can use the ArcGIS Pro. If you want to develop an application which is related to create a maps and perform the spatial analysis and manage the data, you can use the ArcGIS Desktop. For visualization, analysis, and management of geospatial imagery and scientific data, you can go for the software name that is ENVI. Then QGIS software is used for viewing, editing, printing, analysis of geospatial data. Then GRASS GIS is another software which you can use for terrain and ecosystem modeling and hydrologic and visualization of the raster and vector data management and analysis of geospatial data, and also processing of satellite and aerial images. So for that you can go for GRASS GIS. Then GeoMedia is another software which you can use for a single unified map view for efficient processing and analysis, presentation, sharing of data, and providing a simultaneous access to the geospatial data. Then Map Info Pro can be used for visualize and analyze data, edit it, then interpret and output the data. And it helps to better understand the visualized data through the map symbols, themes, and labels. So Global Mapper is another example of software which provides both the novice and the experienced geospatial professional with the comprehensive area of spatial data processing tools. And Global Mapper supports more than 300 spatial data formats. So here we will see the machine learning concepts for smart city development. For development of e-governance system for the municipal corporation, the high resolution satellite image are essential, but the image covers the large area and we have to identify each object, then properties, then building, etc. From the image. But it is very difficult through conventional method like visual inspection, or you can by selecting object one by one. So to select all the homogeneous and heterogeneous objects from the satellite image, we have to use the machine learning approaches. So yeah, remote sensing and GIS with the addition of machine learning algorithm helps to perform various tasks for the development of e-governance system as well as for the smart city development. The classification of building and various objects are done by mostly from the supervised learning algorithm. So some of the so we will see some supervised learning algorithm, like if you want to identify and recognize algorithm. If you want a grouping of various objects, then you can go for k-means clustering algorithm. Then extraction of building, those having a rooftop and those are not having a rooftop, that can be done by using a classification algorithm such as logistic regression, linear discriminant analysis, LDA, and SVM also you can use for it. To identify the greenery and shadow of trees, you can go for and the vegetation indices also provided by these algorithms. According to the literature review and researchers, the higher accuracy given by the SVM classification algorithm. The machine learning techniques are help for developing a smart cities and government agencies as well as in every research field. So remote sensing and GIS software have a machine learning algorithm like SVM and random forest, and these have the good accuracy comparative with the other available algorithm. The algorithm work efficiently when we take care of the input data and the parameters which we providing to algorithm for the training. So this is the conclusion of my presentation is the remote sensing and GIS with the help of machine learning technique have enormous use for the design and development of e-governance system, and also helps with the smart city development. The previous study and the research work done in this paper shows that the high resolution satellite images like Worldview 2, Sentinel, then Iconos, QuickBird, and so on help for the recognition and identification of various type of objects, building, empty places, playground, greenery, and from large area of the city. And this can help for designing e-governance system with the help of remote sensing and GIS and machine learning algorithms. So in the satellite image, various objects are present to extract and classify those objects. Supervised machine learning algorithm are widely used because of their accuracy and enormous advantages. So this research work shows that the SVM algorithm machine learning technique and the Worldview 2 high resolution satellite image are good for the development of e-governance system to contribute for the smart city development projects in the form of technology. So these are different references which I referred for the development of my project for this paper. And I want to extend my thanks and gratitude towards my guide, Dr. Ratnadeep R. Deshmukh, sir, professor in computer science and IT department, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, India, and my colleagues also. And I would like to thanks to Department of Science and Technology under the Fund for Infrastructure under the Science and Technology GST FIST with the sanction number SR FST ETI 3402013 for providing the infrastructure for this research work in the Department of Computer Science and Information Technology, BAMO University, Aurangabad, Maharashtra, India. Thank you. So questions?
Thank you very much, Ms. Banga, for your presentation. Do we have any questions from the audience? There seems to be no hand from any of the participants. Thank you once again for your presentation. So we have come to the end of the first session. So we are going on a 10-minute break. And
thank you, ma'am. Thank you, ma'am. Thank you all.
So we are going for our tea break now. See you all after the 10 minutes break. Thank you.
After the tea break, we are going to have our breakout sessions. They are already open. So the way we identify our breakout session for those logging online is with the program, like for the ones where you actually see the DSMLAI 2 repeated twice, we have made it easy to identify by the chair of that session. And we also indicate maybe the first 2 or first 3 papers found in a particular session so that at least you're guided accordingly as well. We'll give, maybe we'll display the instructions on how to join those breakaway sessions online. And for those joining us physically here, we are going to be using this venue and the next venue for the 2 sessions. If there is a 3rd session, we'll actually use another meeting room that side. So we actually have this venue and the next venue as for parallel sessions. So we actually identify them as follows. For DSMLAI 1, it will continue in this venue. Let me just make sure that I don't mix things up here for those physically here. Right, so we have DSMLAI 2. That will actually use this venue. Then DSMLAI 2, since these are the 2 that are actually named twice on the program. So the one being chaired by Dr. Azeta for the physical attendees, we are actually in this venue. Then the one being co-chaired or being moderated by Mr. Mtempo, the DSMLAI 2, or which is having the chair 1 is Prof. Shirag, and chair 2 is Dr. Krishna Singh. That will be the next venue for those that are physically here. So these are 2 parallel sessions that we're going to have after tea break. Any clarity? Yes. Okay, perfect. And for our online attendees, in case you have any issues, please just drop us a message on the chat. We should be in a position to attend to you, and we're actually also going to share a screen that gives you instructions on how to join the parallel sessions after tea break. See you shortly.
So,
This one.
I've sent 2 presentations. I've sent 2 presentations.
So it is very direct because when you see
Which,
remember it can take years here.
this one?
Yeah. It's very we present direct picture to your private presentation.
Because one presenter asked me to load their presentation.